All right, so I want to give you a quick run through of how to use the graphing tool for exponential and logarithmic equations. I'm going to go ahead and click there. We get this guy. This button in the top right, the exponential tool, is the one you want to click on. You can click anywhere in the graph now. It does not matter. It draws you a very basic exponential curve. Now, if you look at this box right here, this is all the details we need. There's vertical and horizontal stretching and shrinking. We have not discussed horizontal, so you don't need to worry about that showing up anywhere. We'll come to the vertical here in a second. We've got shifting up and down vertically, shifting left and right horizontally with sliders, and then reflecting across the axes. And then lastly, the actual base that you're working with in the problem. So you can change this number by simply typing in a new number. If I wanted to say this graph was actually stretched by a factor of 2, which would be if there was a 2 out front of the problem, out front of the exponential base. Notice when I click off of this, you're going to see this whole graph get stretched up. All right, we know stretching multiplies every y value by that value, increasing its value. So I'll set that back to 1. These two are very straightforward, vertical and horizontal translation. That's the shifting. So you can shift it down and up with that slider, and left and right with that slider. You can also reflect it, which is the idea of flipping it around an axis. Reflecting about the x-axis, that's the flipping up and down. That's the vertical flipping or vertical reflection. So it does that. Reflecting about the y-axis is treating y like the mirror, so it's flipping it left and right like that. And then lastly, if this base is not the base of your actual problem, you can even adjust it. Notice I could replace e with a 2. It'll change this important characteristic point that we have, right? We have 0, 1 for all of these, but we have the point 1 comma e here. This is the roughly 2.7. If I change this base to a 2, that important point turns into 1 comma 2. So you can even change the base if necessary, but generally speaking, I believe the problem defaults to whatever your base is in the given question. So that's it. You plot that graph down, and then you adjust it. So for this one, just a quick review, the -2 up there in the exponent is affecting the x, and we know that that is going to give us a horizontal shift left and right. We also know that with horizontal shifts, we kind of think opposite. So with that -2, we don't actually shift left 2, we'll shift right 2. So I'll shift that right 2. Notice that important point of 0, 1 is now over at 2, 2. That point was shifted right 2. Then the -1 here on the outside of the function, we know that affects the y. That's the vertical shift. And -1 will take us down 1. So the vertical slider, I'll pull down 1. Now that point that just got shifted over 2 has now been shifted down 1. And you have the graph. If you just exit out of there, you have the graph of your actual function. Now, the other thing that you need to graph here, and some problems have it worded a little better than others, they want you to also graph the asymptote. We know that with an exponential function, they have a horizontal asymptote. We see this behavior. This line getting closer and closer and closer to this line right here. This one actually just keeps going up and to the right. But we've got asymptote behavior right here. And it's actually as simple as knowing that all we did is shifted this down 1. So the original asymptote for any exponential function is on the x-axis. It's at y equals 0. We need to draw a line right here at y equals -1. So I want to shift from this graph. I want to draw a straight line. Also, I'm going to go ahead and use this dotted line as it's just representing our asymptote. It's not representing a part of the graph. It's not the function itself. So we're going to represent the asymptote with a dotted line here. And just click any two places that draw yourself a horizontal line there at y equals -1. And I will save that. And so there's our graph with asymptote. And I will check it. And we're good to go. Beyond that, you're just answering the questions of what's the equation of the asymptote, what's the domain and range, things of that nature for the remainder of the problem. Hope that helps.